Good morning, my dear Prep 1 students. Hope you are all fine today. In today's video, we are going to solve more examples considering rational numbers. But before we go and start with our first question, let's first remember what were rational numbers. A rational number was a number that can be written in the form of a over b. In other words, it can be written in the form of a fraction. The second condition was that my numerator must belongs to z or must be an integer, and my denominator should also be an integer, meaning that both my numerator and denominator should be whole numbers, either positive whole numbers or negative whole numbers. The third condition is that b is not equal to 0, and this b is my denominator, so my denominator should not be equal to 0. We also said that rational numbers contains decimals, integers, and percentage. Did you remember now what are rational numbers? So let's go and start solving our first question, which is a multiple choice question. Let's go now for the first one. The necessary condition to make 7 over x minus 3 a rational number. I am already given the number in a form of a fraction, and the most important or the necessary condition to make a fraction a rational number is that my denominator is not equal to 0. So in this case, I am saying that x minus 3 should not be equal to 0. By solving it as the normal equation and moving the minus 3 to the other side, I will have now x is not equal to 0 plus 3. So x is not equal to 3. The correct answer here is number C. X is not equal to 3. Let's go now for the second one. The necessary condition to make 7 over x plus 5 a rational number is x not equal to. Again, I was given the number already in a fraction form. And the necessary condition to have a fraction a rational number is that my denominator should not be equal to 0. In other words, I am saying here that x plus 5 is not equal to 0. Moving the 5 to the other side with the inverse, x is not equal to 0 minus 5. So x is not equal to negative 5. And the correct answer here for this question is number A. X is not equal to negative 5. Let's go now for the third one. He's telling me that if 5 over x minus 4 belongs to Q. What is the meaning that it belongs to Q? This means it's a rational number. So, in other words, he's saying to me that 5 over x minus 4 is a rational number. And we said that to have a fraction as the rational number, the most important condition is that my denominator is not equal to 0. X minus 4 is not equal to 0. Solving it as an equation and moving the minus 4 to the other side, I will have now x is not equal to 0 plus 4, which means that x is not equal to 4. So my correct answer is number D. Let's go now for the next one. 7 over 3 minus x belongs to Q. And we said that when I have belongs to Q, this means that this number is a rational number. So I already know that I have a rational number. The most important condition for a rational number is that my denominator is not equal to 0. In other words, I am saying that 3 minus x is not equal to 0. I am going to move the 3 to the other side. Negative x is not equal to 0 minus 3. So, negative x is not equal to negative 3. Now, I am looking for x is not equal to what? Not negative x. What can I do to take away this negative sign? Simply, we are going to cancel it from here and from here as well. So as a result, I will have here that x is not equal to 3. And this is my correct answer, which is number D. Let's go now for the second one. The number 0.5 equal in a rational number form. So he wants me to put this 0.5 in a rational number. We said that we can easily put a decimal in a rational form or in the form of a over b. How? Simply by counting how many decimal places do I have, and I have here only one decimal place. As a result, I will have my denominator as 10. And then I will put the number without the decimal. So my correct answer here is number A, which is 5 over 10. I would like you please to concentrate with me on the next 3 questions. Here he is telling me that if x plus 3 over x minus 7 equals 0, then the value of x is, we already agree that a over b, or anything that can be written in the form of a over b, is a rational number. My numerator should belongs to z, and also my denominator should belongs to z. And we said that b, which is my denominator, should never be equal to 0. Now he's telling me that this is a rational number and it's equal to 0. When I am going to have a fraction equal to 0, if you remember, we have studied before that, for example, if I have 0 over 5, this is going to be equal 0. 0 over negative 4, this is also going to be equal to 0. In other words, I can say that when my numerator is 0, I am simply going to have an answer of 0. This means that in this case, I want x plus 3 to be equal to 0. So, x plus 3 equals 0, solving it as an equation and moving the plus 3 to the other side, I will have x equal 0 minus 3, so x is equals to negative 3. So my correct answer here is number A, x is equals to negative 3. Let's go now for the next question. The rational number x minus 7 over 5 equals 0 when, again, I know that it's a rational number, and for a rational number to give me the result of 0, my numerator, which is x minus 7, should be equal to 0. X minus 7 equals 0. Moving the minus 7 to the other side with the inverse, I will have here now x equal to 0 plus 7. So x is equal to 7. My correct answer here is number B. Let's go now for the last multiple choice question. If the rational number x minus 3 over x minus 5 equals 0, then x equal. Again, I already know that this is a rational number. And for a rational number to be equal to 0, my numerator should be 0. In other words, I am saying that I want x minus 3 to be equal to 0. I will solve it as an equation and move the minus 3 to the other side. X is equals to 0 plus 3. So x is equal to 3, which is answer A. Let's go now for the complete questions. Again, we would like to remember that a rational number is any number that can be written in the form of A over B, and that my numerator should always be an integer, and my denominator should always be an integer. And the most important thing is that my denominator is never equal to 0. So let's go now and begin with our complete questions. The number 4 over x is a rational number. He's already telling me that 4 over x is a rational number. And we said to have a fraction as a rational number, my denominator should never equal 0. Now he's asking about x, and x is my denominator. So as a result, x is not equal to 0. Let's go now with the second one. If a over b plus 5 is a rational number, then b is not equal to, I already know that this number is a rational number. For a fraction to be a rational number, what is the most important condition? Exactly. The most important condition is my denominator is not equal to 0. So I am saying that b plus 5 should not be equal to 0. So b is not equal to 0 minus 5. b is not equal to negative 5. Let's go for the next one now. X plus 5 over x minus 7 equals 0. Then x is equal to, we said before that when I have a fraction is equal to 0, this means that I am looking at the numerator and I want my numerator to be equal to 0 in order to have this fraction equal to 0. X plus 5 is equal to 0. I will move the 5 to the other side with the inverse. X is equal to 0 minus 5. So x is equals to negative 5. Let's go now for the next one. If x minus 5 over x minus 7 equals 0. We said that, again, for a fraction to be equal to 0, this means that my numerator is equal to 0. In other words, I am saying that x minus 5 is equal to 0. And this is an equation. To solve it, I'm going to move minus 5 to the other side. X now is equal to 0 plus 5. So x is equals to 5. Let's go now to solve more complete questions. We are going to begin from number 3. If a over b is a rational number, I already know now that a over b is a rational number, and we said that to have a fraction as a rational number, I must have my denominator is not equal to 0. And here he is asking b is not equal to what? And b is my denominator. As a result here, I will have b not equal to 0. Let's go for number 4. The number 4 over x minus 3 is rational. If x is not equal to have again a fraction as a rational number, the most important condition is that my denominator is not equal to 0. So I am saying that x minus 3 is not equal to 0. I will move the minus 3 to the other side and solve the equation. X is not equal to 0 plus 3. So x is not equal to 3. Let's go now for number b. X plus 5 over x minus 5 is a rational number if x is not equal to, again this is a rational number, and for a number to be rational or a fraction to be rational, I must know that my denominator should not equal 0. So, in other words, I am saying that x minus 5 is not equal to 0. By moving the minus 5 to the other side, I will have x is not equal to 0 plus 5, so x is not equal to 5. Let's go now for number 6. The rational number 5 minus x over x minus 4 is equal to 0. If x is equals to, he's telling me that the rational number is equal to 0. We said that for a rational number to give the result of 0 or to be equal to 0, my numerator should be 0. In other words, I am saying that 5 minus x is equal to 0. I am going to move the 5 to the other side. So negative x is equal to 0 minus 5. Negative x is equals to negative 5. Here, I am looking only for x. What should I do to take away the negative sign? I am going to cancel it from both directions. So I will have now x is equals to 5. And if we check now, you will find that 5 minus 5 over x minus 4 is equal to 0 over x minus 4. And this is exactly what I need, my numerator to be 0. Let's go for number 7. The rational number a over b is an integer if. Where should I know that? A fraction or a rational number is an integer. Simply, for a fraction or a rational number to be an integer, a, which is my numerator, should be divisible by b. So to say that this is a rational number, my numerator should be divisible by my denominator. Or by other words, number 8 express 0.57 as a rational number in simplest form. We said that to find the decimal as a rational number or in the form of a fraction, simply we will go and count how many decimal places do we have. And in this case, we have 2 decimal places. As a result, I will have my denominator over 100. And then I'm going to put the number as it is, but without the decimals. 57 over 100 is in the simplest form because simply there is nothing common between 57 and 100 that I can divide with. Number 9, the rational number x over negative 4 is negative if x dots 0. Here I want to find the relation between x and the 0. Let's remember that we studied before in primary 6 that negative number divided by negative number, I will have a positive number. And a positive number divided by a negative number, I will have the answer of negative number. So here, let's concentrate. We said that he wants it to be negative. He wants x over negative 4 to be a negative number. I already have my denominator as a negative number. So, in order to have the answer in negative, I must have x in a positive number. How should I have x in a positive number? To have x as a positive number, simply I want all the numbers that are greater than 0. So in other words, I am saying that x is greater than 0. Let's go now for number 10. If a over b is a rational number and ab equals 0, then a is equal to, we agreed before that the meaning of ab is a times b. When I am going to have a times b equals 0, simply when I have one of the two factors equal to 0. And I know that b is my denominator, so no way that b is equal to 0 since a over b is a rational number. In this case, I'm saying that a is equal to 0. Now we have covered more examples on the part that I explained and reached the end of our lesson.